Good afternoon, everyone. I hope you're all having a wonderful day, and I certainly hope that wherever you are in the world, that it's much better weather than here as it is in southwestern Pennsylvania. We've had the whole gamut today, from rain to sleet and now snow, so I certainly hope your weather is much nicer than ours. Thank you for taking time out of your busy day to join us. My name is Lindsay Pecosh. I am the Associate Director of Graduate Admissions and Global Online at California University of Pennsylvania. It is my pleasure to welcome you to the first in our spring webinar series. Today's webinar, Top 5 Emerging Data Science Tools, will cover the industry's trends of big data analysis, why it's sweeping the nation, what tools are currently being used to work with it, and demos of each tool's capability in the field. It's my honor to introduce to you a leader in the big data industry, Dr. Melissa Sovak. Dr. Sovak is an associate professor here at California University of Pennsylvania. She has a Ph.D. in statistics from the University of Pittsburgh and an MS in Computational Mathematics from Duquesne University. In addition, she holds several certificates in data science and data science-related courses from Coursera and is an SAS certified base programmer for SAS 9. Additionally, Dr. Sovak is a program coordinator for CalU's PSM in Applied Mathematics graduate program and CalU's new BS in Statistics and Data Science program. This afternoon, following her presentation, we will have time for a Q&A segment. So if throughout the course of the presentation you think of questions you'd like Dr. Sovak to answer for you, just send it through the chat function and send it to me directly, as I'll be compiling the questions for the Q&A at the end. And without further ado, I'm happy to turn everything over to Dr. Sovak for the webinar. Dr. Sovak?
Thanks, Lindsay, and welcome everyone. I'm glad that you're joining us today for this webinar about data science. So I'm excited to get started, and we're going to cover a few different things today, including a little brief introduction and welcome from us at CalU, an introduction to myself, go over what data science actually is and how it's influencing the industries today, and then take a look at what tools are important in this new world of emerging data. So let's go ahead right into the introduction. So again, just a welcome from myself and from CalU. We're happy that you're here learning more about data science. This is my 8th year at CalU. As Lindsay mentioned, I have my PhD in statistics from the University of Pittsburgh, and I've stayed really current in my field with over 15 certifications from Coursera in courses including data science, Python, and related types of coursework. And I recently just became a SAS certified base programmer, and I'm pursuing additional SAS certificates now as well. And I'm the coordinator for our graduate level program in Applied Mathematics, which has a big data focus as well, and our brand new Bachelor of Science in Statistics and Data Science that will debut in fall of 2018. So let's move on to finding out what data science actually is. So this is a really big buzzword that's going around right now. Data science is a really popular term, but what actually is data science? So data science is officially defined as an interdisciplinary field of scientific methods, processes, and systems to extract knowledge or insight from data in various forms. And we're going to see, as I mentioned, an interdisciplinary field. We're going to see theories coming from mathematics, statistics, information science, and computer science. So we're pulling on a lot of different fields to pull this together. Namely, mathematics, where we'll pull on calculus and linear algebra types of knowledge, statistics, where we'll pull on exploratory data analysis and hypothesis testing, information science, where we'll get database management and use for managing our large amounts of data that we have, and computer science, where we're writing custom code for specific types of analysis. And one of the big things we're seeing in computer science right now is the explosion of the use of Python. So you'll notice that I listed that in my list of credentials on the previous slide. And Python is really something that is kind of exploding onto the scene of data science right now. So we're seeing this combination or coming together of all of these different fields to form this new field of data science. And now what I wanted to talk about a little bit on this slide as well is what actually is big data. So what's the difference specifically between just data and big data? So data we're pretty familiar with. We all kind of have a vision of what that looks like. We always think of a spreadsheet with rows and columns, rows representing the subjects in a study and columns representing the variables in a study. And certainly we can have that type of big data as well, but there is a lot more involved in truly big data than just a typical spreadsheet of information. So what actually defines big data as being big data is what we call the 3 V's. So this is volume, velocity, and variety. So if we have these 3 things in place, then we have truly big data. Now when we say volume, we mean we have a large amount of data, and that I think makes sense to everyone. That's what everyone would think of when they're thinking about big data. Oh, it's just a big, massive amount of data. But it's actually a very large amount of data. And just to give you an idea, we probably are all familiar with the term gigabyte. So most people's hard drives are measured in gigabytes. But in recent years, we've seen hard drives begin to be measured in terabytes. So terabytes are 1,024 gigabytes. And we've just kind of seen people's hard drives start to be measured in terabytes, but it's still not a really familiar term, but it's over 1,000 gigabytes. Now, when we're talking about big data, we're actually talking larger than that. So we're defining new terms called petabytes and exabytes. So petabytes are over 1,000 terabytes, and exabytes are over 1,000 petabytes. So we're talking about measuring data in 10,000 to 100,000 times what you're used to seeing on your hard drive on your personal computer. So it's very large amounts of data. The second thing that goes into making big data is velocity. So we're talking about data that's generated very, very quickly, in addition to just being large amounts. So think about the number of posts on Facebook every minute. There are thousands of posts made on Facebook every few seconds to every minute. So we see massive amounts of data coming in, and it's generated very quickly. Every second someone somewhere is posting something on Facebook or Twitter or some form of social media. So we have large amounts of data coming very quickly. And the last piece is variety. So typically when we think of data, we think of the nice spreadsheet with rows and columns. But when we're talking about big data, we can actually have data coming in multiple formats. So it's not just rows and columns, variables and subjects in a spreadsheet. It can be text, pictures, videos, files, etc. So these are the 3 things that make up big data. And again, if you think of the Facebook example, you can see large amounts of data coming very quickly and in multiple forms. Most people are posting things that have text, video, pictures, hashtags, those types of things. And we're looking now into analyzing, because we can get a lot of information from people's Facebook posts, as we know. We're looking into analyzing these different types or these unstructured types of data. So how is data science influencing our industry? Our data is coming in to almost every industry at record speeds. So if you think about it, almost everybody generates data almost all the time now. My smartphone is right in front of me, and every moment that I check it or that I carry it from place to place, I am generating some form of data. That's how it knows to tell me the weather when I drive from my home to California University. It knows to change cities and so on because I'm generating data from that smartphone. Our cars are generating data. If you have a car that calculates average mile per gallon while you're driving and so on, that's generating data. Internet browsing, we leave a breadcrumb trail everywhere that we go. So clickstream data is another way that we're seeing lots of data come in. And it's pretty pervasive. It's in almost every industry that we've seen that the large amount of data of coming in and being generated all very quickly. Now what's new is this is the first time that we're ever been able to harness this amount of data and then do analysis on it. And we can do analysis very quickly on it. So this is really the first time we've ever been able to do that. We now have the mechanisms to house this amount of data, and we have the mechanism to actually analyze this amount of data. And just to give you an idea, we talked a little bit before about the size of this data being in petabytes and exabytes. To give you an idea of how quickly this data is flooding in, the internet actually handles 21 exabytes of data per month, and that was a measurement that was taken back in 2010. So we're 8 years out from that, so I can imagine it's even more than that. But 21 exabytes per month of data generated by the internet. And what we're finding is this information can help us to improve profits, can help us to make decisions, can help create unique user experiences. So we're seeing now that we have all of this information and we're really able to actually analyze it. In some cases, we're getting close to analyzing in real time as the data comes in, that companies like Amazon, Google, Netflix, Lyft, Uber, Stitch Fix, just all across the map are using this data and some of the tools that we're about to talk about in order to improve the way that their business runs. So Amazon is always looking to improve the way that Alexa responds to requests, or the way that your website looks when you go on to shop at Amazon, so they can suggest products to get you to a purchase. They're interested to see how you've gotten to their site. Did you go straight to Amazon? Did you click on an ad? Where was that ad from? Is it useful for them to advertise on Facebook? Is that not useful, etc.? Companies like Lyft are looking into self-driving vehicles. They're using massive amounts of data to improve that, to make sure that the vehicles are safe. And companies in the fashion industry like Stitch Fix are using massive amounts of data to provide good customer experiences, so that when they ship out the 5 items that you receive in your box per month, that you have a good selection, they've hit the mark, and they're not getting lots of returns back, for example. So let's take a look at some of the 5 tools that are really important in this new frontier of data analysis. So the 5 tools, and there are many others out there, but these are kind of the major players within the industry, are SAS Visual Analytics. Those are 2 separate things, as I'll show you. Hadoop, Tableau, and RapidMiner. So let's take a look at our first emerging tool, SAS. So SAS is one of the largest players in the market. They're used in over 80,000 workplaces. They have about a 33% market share in data analysis. They're a powerhouse for data analysis. They can pair with Hadoop, as we'll see later, and they really are the big name here. Now, if you're familiar with SAS at all, you know that back in the day, so back in the day when I went to graduate school, this was all coded. So you had to be a SAS programmer in order to use the software. That has all changed now, so we have a new interface that provides better access for people who are not familiar with coding in SAS. So as I'll show you here in this small screenshot that we have here, you can see on the right-hand side some of the traditional SAS codes for inputting. In this case, we're inputting patient data from a hospital. And you can see, you know, what the code would look like there. But if you take a look on the left-hand side of the screen, you'll see there's a new menu called Tasks and Utilities. And you'll see several different things there, like graphs, statistics, and so on. And I have the statistics menu open for us to take a look at. And if you take a look there, you'll see summary statistics, one-way frequencies, t-tests, one-way ANOVAs, all things that we would use to analyze data. And this is now point and click. So if you would double click on one of those, it will open up a window. You'll fill in a couple of boxes to tell the data what data to use, to tell SAS what variables to use, and so on. And then you'll click a button and everything will be run for you. So it auto-generates the code, which is very different from what it used to be. So because this now can be used by a larger range of people who don't need to know how to code, this has really become a heavy hitter in the field for data analysis. Now, if we take a look at emerging tool 2, this is SAS Visual Analytics, another product from SAS Institute. This is an extension of the SAS software, and this is meant to provide an expansion for visualization specifically. Now, what's very nice about SAS Visual Analytics is that there is no coding at all required in any way, shape, or form. It's all drag and drop. So if you take a look at what SAS Visual Analytics can do here, you'll see that we have a dashboard that kind of looks like this. Over on the side here, we have a list of variables that are available for us to analyze, and you can open up multiple tabs. You can select graphs here and then just drag the variable in that you would like, or you can start with an empty field and drag the variable in, and this is another very nice feature of SAS Visual Analytics. SAS Visual Analytics will actually determine which graph should be used. You are always free to change that, of course, but it will analyze the information that you're giving it, and it will go ahead and suggest a graph for you to use. So that's a very nice thing as well for people who don't have a lot of training in visualization of data or statistics. So it makes it very easy to create and read different types of graphs. Now, if we look at our third emerging tool, Hadoop. This is another big player in the big data world because it makes things very quick and very easy to analyze big data across systems. So this can be actually paired with programming languages. You can use Python, SQL. We can pair this with SAS, which is one of the things that we do here on at Cal U. We have SAS and Hadoop running together so that you can push things through SAS into Hadoop. And there are several different tools available for data analysis in Hadoop, including things like MapReduce, Pig, Scoop, Hive. And we can do text analytics with some of these. We can do database queries with Hive. And the key thing with Hadoop is that it's meant to run with big data. So it's very good at processing big data. So the reason that, for example, we would pair it with something like SAS is because SAS is very good at running analytics, but not good at managing data. So we leave the managing data on the Hadoop side, and we use the commands through the SAS interface, and we push them over and let Hadoop do all the management of big data for us, and then we get our results back in SAS. So these are very nice when paired together. And just to give you a look at what Hadoop is like on its own, and again, you know, this can be paired with a SAS interface. But if you take a look at what Hadoop looks like on its own, here's our Hue browser for Hadoop. There are editors in here to run things like Pig, write Java code, run Scoop, run MapReduce, query in Hive for massive database tables, and so on. And just to show you what some code might look like, because this is more code driven, you have to write your own code. This is some Pig code here that was run a few months ago for some of our coursework. So you can see we're doing some text analytics here. We're actually parsing apart a particular file, and then we're generating word counts. And that's something that's very useful if you're pulling data down off of, for example, Twitter or Facebook on a particular product. So you go to the Samsung website on Facebook, and you pull down comments about the Samsung 9, and then you run it through a text analytics and see what words are popping up most frequently. For example, you know, are they positive, are they negative? You can generate word clouds and things like that. So this makes this a very nice tool for doing lots of big data analysis, whether it's structured big data in a table or whether it's textual type of big data. So looking at our fourth emerging tool, which is Tableau, this is another nice data visualization product that's focused on business intelligence here. And this one is very, very powerful. So let me pop into the example that I pulled here. This is one of the great examples that Tableau provides. You know, is your county obese? And you can see the the different types of visualizations that you can produce very easily, very seamlessly in Tableau. Again, this is point and click, no code is needed, and you can drill down into each county and each state, county, towns, and so on and so forth. But it creates really nice graphics, so a nice location map here created in Tableau. These are the types of visualizations that we're seeing come to play now, that we can actually do this type of analysis. Gone are the days of just pie charts and bar charts. We're now doing much more interesting visualizations like heat maps, location maps, and so on and so forth, like this particular display here. And Tableau makes it very easy to do this, very easy to drill down into specifics, and so on. And now our last tool, RapidMiner. So this one is a data science software platform. It provides an integrative environment for data preparation, machine learning, deep learning, text mining, and predictive analytics. And I pulled an example here as well. And this is just the tip of the iceberg for what RapidMiner can do. It's a great software for business intelligence, but this one's just creating a tree model for decision making based off of particular variables. It can do, as I mentioned, predictive analytics or text mining, which is very popular as well. Now, that was just a very brief overview of some of the tools that we see emerging in the data science world here. If you're interested in learning a little bit more, here's our shameless plug. We do have several programs that go through many of the softwares that we talked about, including our graduate PSM program in applied math, where we do have a big data focus. We offer SAS certificates in data science at both the graduate and undergraduate level. And of course, our new Bachelor's of Science in Statistics and Data Science. And you do learn SAS software, you do learn Hadoop, and you do learn Tableau in those courses that make up our certificates and our Bachelor of Science. So I want to take a minute to thank you all for listening, and then I'd like to turn it over to you for any questions that you may have.
Wonderful job, Dr. Sovak. Thank you so much. I'm sure everyone learned a great deal about the emerging tools. I know I certainly did. And I just have to tell you all, I asked Dr. Sovak before we got started today if the correct pronunciation was data or data, and she said that they can be used interchangeably. So thank you for clarifying that, Dr. Sovak. But we have received quite a number of questions. So if you are ready, Dr. Sovak, we'll get right into the questions that came in.
Sure.
Okay. First question is, how is big data different from data?
So the main difference is, like I said, if we go back to those 3 V's, so just traditional data is typically what most people think of. They think of, asking people to answer questions on a survey, and you fill it in on a spreadsheet whether or not they said yes or no to a particular set of questions. You maybe have 20 variables and 100 participants. When we're talking about big data, we're talking about millions of columns worth of variables that we're looking at and billions of rows of data. So that's one of the major differences. The other difference is, again, in how quickly the data is generated. So again, we use the Facebook example. If we use another example, think about Amazon, how many purchases are made every second on Amazon. It's a massive amount of data that's all being housed in some large database. And if you even go to a smaller scale, I have the Giant Eagle loyalty card. I go in and scan it because I want to get my fuel perks, and every time I scan it, guess how much data they're collecting? They're collecting exactly what I buy, when I buy it, how often I buy it, how often I come into the store, and so on. So, every industry is being hit by these very large amounts of data. So that's one of the key differences, is just size, how fast it's generated, and again, the format that we see, because again, Facebook posts aren't all just answers to questions. I mean, there's people that, are writing massive amounts of text on there that we can take and analyze.
Okay, great. Next question. Why are we seeing so much data now?
So this is really because of the advent of not only the internet, but the fact that we're all connected almost all the time to the internet in some way, or to a database in some way. So most of us have PCs, most of us have smartphones, a lot of us have other smart devices in our home. So for example, in my home I have a Nest thermostat which can connect to my cell phone, my laptop, and my Alexa. So, you know, I can use Alexa to control the thermostat. It's on my Wi-Fi. It's generating data all the time to let me know whether or not I've had a productive month in terms of, you know, I kept my thermostat warm enough or cool enough to generate an efficient savings in my house. It's also constantly monitoring me to see if I'm leaving the house, because then it can kick itself down and so on. So it's generating data all the time, and it's these types of devices where we're really seeing this big boom in data, because these things are constantly connected and they're constantly monitoring and they're constantly improving how they monitor.
Okay, next question. What is the meaning of analyzing data?
So there are many different meanings to analyzing data, and it really depends on the data that you have and the outcome that you would like. So analyzing data can be as simple as pulling some graphics to show exactly what's going on in the data. It can mean exploring the data. So in many cases, big data analytics takes the form of an exploratory data analysis. And the difference between that and, for example, hypothesis testing is that in hypothesis testing, we have very specific things or questions that we want answers to, and we have those questions formed before we see the data. Oftentimes with big data, what we find is we don't know what questions to ask. So we don't know, we have these massive databases, but we don't know what is the relevant question to ask, but we know we have lots of information and we want to try to use it. So what we can do is what we call an exploratory data analysis, where we just go into the data and we mine around in the data to see what we have. One of the best examples of this is what we call market basket analysis, where companies like Amazon or a supermarket or something like that wants to know, what do people typically buy together? So for example, if I go on to Amazon and I buy a particular beauty product, can they sell me another beauty product, or do I want a related product? Or maybe I'll be looking for hairspray when I'm looking for mascara or something like that. Do I typically buy those types of things together? Because that will help them market and product place, so that instead of me spending $10 at Amazon, I can spend $50 at Amazon, because when I put my mascara in the cart, I can say, oh, that's right, look, good thing they popped this up. I also need this. And then I can click on that to buy as well. So analyzing data can take on a lot of different forms. It really depends on what it is that you're trying to get out of the data and how much you know ahead of time about what you want from it.
Okay, great. Can these tools be combined?
Yes, so as I mentioned, we do have the ability to combine some of these tools. So for example, SAS and Hadoop can actually be combined. We run both on campus here. We can use Hadoop on its own, we can use SAS on its own, but one of the most powerful ways that we can use them is together. And that's because SAS is very good at certain things, and Hadoop is very good at certain things. So we let them do the things that they're good at, and we use one interface to process instead of having to learn two, and then we let Hadoop do what it's good at, which is big data management and pulling information out of big data, and we let SAS do what it's good at, which is interfacing and reproducing results on the screen for us. So we can put them together.
Next question. Are any of these degree programs available for distance education?
Yes. So our graduate program and both of our certificate, grad and undergrad, are all 100% online. So students can take those from wherever they are in the world. We're very flexible in those programs, so we do understand that students do come from all over the world and have very varied schedules. So we use an asynchronous format for those. For the Bachelor's of Science, we're about 60% online, and if you want to if you're coming from somewhere else and you want to transfer coursework in so you do not have to complete a face-to-face component, we can make sure that you work with an advisor to make that happen as well. So at least 60% of your coursework in that bachelor's would be online, but you can choose to have more online as well.
Next question. Do you know some companies that are using Hadoop?
There are a lot of companies that use Hadoop. Companies, massive companies like Netflix and Amazon rely on that type of technology in order to process data because their databases are just so massive that they probably couldn't fit them into any other analysis tool.
Does a data scientist have to learn all the emerging tools or just need to know some of them?
So it depends on what you're going to do and what type of work you're going to be doing. So in some cases, you may want to have a variety of tools in mind because it depends on what level you're going to be at, who you're going to be presenting to, and so on. But you don't have to know every tool. A data scientist really should have 2 or 3 tools that they're excellent at using instead of 20 tools that they're just average at using.
How can businesses begin to harness data's power?
So one of the ways is just taking a look at some of the data that you already have. So, a lot of times there are things that are already being collected that businesses don't realize is available to them. So, look at what you're collecting already and then see if you can use that to your advantage. And another way is if you're kind of a smaller business, but you still want to kind of get in there and do some data analytics, but you don't have a statistician on staff, is to come to a university like California University, because we have lots of students that are looking for projects to analyze data. And we have lots of students that are very adept at using these tools. So if you're not adept at using these tools, we can set you up with somebody who is. And that's all guided by an instructor, an advisor who oversees that. So you can really start to learn about the data that you have, even if you don't have the expertise to do that yourself.
Are there differences between big data analysis and data analysis?
Yes, there are some differences. Some of them things are going to be the same, but there are some differences because of the differences in the data. So there are some new methods that are coming out, and in particular, the one I'll mention again is text analytics, which is not something we have traditionally done in the past in statistics. In statistics, it was almost all frequency tables and means and standard deviations. And now we're seeing this advent of text analytics where we're going through and creating word clouds, for example, in data visualization, which is not something that we traditionally did in statistics before. We're parsing texts and pulling out words and determining, if word frequency in this particular text suggests that it was written by an author that we have many other texts for. So there are some differences between data analytics and big data analytics, yes.
Great. Well, that was the last of our questions. So with that, I would again like to thank Dr. Sovak for an incredible webinar presentation. The recording of this webinar will be emailed to each of you, and I would encourage you to share it with anyone you feel may have an interest in big data tools. And Dr. Sovak, anything additional from you?
No, just thanks for everyone stopping by and taking a listen.
Great. Thank you so much to all who joined us this afternoon, and I hope you have a wonderful day. Take care.